Now looking at target 8A, properties of rational functions. So our learning objective is I can identify the key features of a rational function. Okay. So our one vocabulary is asymptote. So an asymptote is an imaginary line, doesn't actually exist, that the graph does not touch or cross. Okay? Alright, so we're really focusing on domain, range, increasing, decreasing, and end behavior. Again, these are things we've looked at before. The same rules really apply for the most part, right? For domain, it's all your x values. There's just a few little new things. So we're doing it all together because, again, we've seen most of these things before. Okay? The new thing with all of these is now we have these things called asymptotes. So we're starting with my domain. The first thing I want to look at is any vertical asymptotes. So any vertical lines. Vertical asymptotes is the word I'm trying to write. That the line doesn't cross or touch. And again, they're imaginary. So if you look at this example, sometimes they'll have them dotted in to show like this is where it is. And if you look at this one doesn't really have it in there. Okay, so it might be one or the other. So looking at A, here's my imaginary, let's use a different color. It's in red already. Here's my imaginary line. It passes through the x-axis at 1. Okay. So my vertical asymptote is at x equals 1. Okay. So when I'm looking at my domain is my possible x values. As I go through my x-axis, right, negative infinity is over here. And I'm going, and then I all of a sudden come to this, I like to call them fences. This is a fence that I cannot cross, so I have to stop. Okay, so my domain stops at 1 because there's a fence there. And then right after the fence, it picks back up. Okay, so it's negative infinity to 1, and then 1 to infinity. Usually we combine these with a union. We're saying it's this and then that. It's unioned together, and so it's a little u. Okay, so negative infinity to 1, unioned with 1 to infinity. Now I want to know, is my graph increasing or decreasing? So I usually look at the pieces, right? It's portions of your domain. On this piece, negative infinity to 1, right? I think we should see from here to here, my graph drops, so it's decreasing. And then I'm going to look at my other side. From here to here, again, it's going from higher point to a lower point. Union 1 to infinity. So then with our increasing, is it? We put that symbol, it means empty set. There is no increasing portion of this graph. Alright, now range cares about your horizontal asymptotes, your horizontal lines. I have a horizontal line running straight through here, and it runs through the y-axis at y equals 3. So again, our range starts at the bottom, down here. It goes, and it gets stuck. It has to jump over the fence at 3, and then it keeps going up forever. Okay. Finally, with our end behavior, we have our two different types, right? The limit as x approaches infinity of f of x. Let's do negative infinity first, actually. So that's, again, negative infinity is the left side. F of x is our y. So over here, what's our y value doing? Well, if you look, our y value is getting closer and closer to this line. So our y value is getting closer and closer to 3. Okay? So this number here and this number here, let's put it here, are almost always the same number. Okay? Same thing on the right side, the limit as x approaches infinity of f of x. Close. All right, what's going on this side? It's getting closer and closer to that line. Right. Okay, so it's the right side and it's y. All right, let's look at another one. So my vertical asymptote. Right, you can kind of see it's the line between these two pieces, but they don't touch. It's right there. That's passing through the x-axis at x equals 0. So for my domain, I can go from negative infinity until I hit the fence. I jump over the fence and then I keep going. This one is from the negative infinity to the 0. This section, it's dropping. This section is dropping. So both of the sections we have here are dropping. So there, again, there is no increasing. It's that empty set. All right, for our range, we have to find our horizontal asymptote, which we abbreviate HA. Our horizontal asymptote is straight through here, right? It separates those two pieces. Right, so it's at y is 0. So our range, it starts from the bottom, it goes, it goes, it goes, oh, it hit a fence. So negative infinity to 0. Hop the fence, and it keeps going up forever. Okay. Finally, our end behavior. The limit as x approaches negative infinity of f of x. Okay. This side, what is my y value doing? It's getting close to that line. Then the limit as x approaches infinity of f of x. So this side, right, same thing, it's getting close to that line. All right, next example.
Put it up there.
Starting with our vertical asymptote. Our straight up and down line that we cannot cross is here. So our x values start at negative infinity. They go till they hit our fence, which is at x equals -1. All right, that's where it passes through there. jump the fence and we can keep going forever. Okay. Ooh, hold on. This one has a hole in it. Sorry, we can't keep going forever. Okay. If you look, there's a hole right here. That's between 4 and 6. I'm going to say there's a hole at x equals 5. It's just an open circle. So I would love to keep going, but if I keep walking, if I step on 5, I'm going to fall in a hole. So I can only go from -1 to 5. I have to jump over the hole, and then I can go from 5 to infinity. So looking at the different pieces, -infinity to -1, that's going up. -1 to 5 is going up. 5 to infinity, it's still slightly going up, right? So it's not going up a lot, but it is going up. So all of those are increasing, meaning our decreasing is our empty set. For our range, we have to look for our horizontal asymptote. Okay, our horizontal line is right here at y equals 2. So as I come up here, ooh, I have a hole, right? So I don't want to fall in this hole either. That's on my y-axis at 1. So again, I have to jump over the hole. 1 to 2. Jump over the fence. And then 2 to infinity. Finally, our end behavior, the limit as x approaches infinity, -infinity of f of x. Over here, I'm getting close to that line at 2. As I approach positive infinity, we're also approaching 2. Alright, looking at letter D. We have all sorts of things going on in this one. Let's start with our vertical asymptote. This one has a vertical line here, which it doesn't cross, at x equals -3. It also has a vertical line here, which it can't cross, at x equals 3. If you look, we also have holes. I have a hole here. I have a hole here. I'm just going to list them. I have a hole here. And I have a hole here. So I go through my domain. I'm going through very carefully, and I'm starting at -infinity, right, all the way over here. And then walking and walking and walking and walking. At -4, I have to jump over the hole. Jump. Sorry. Bring that deck down. Then, right, I'm walking and walking and walking, and then I get to a fence I have to jump over. Walking, 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 right? I have to jump over this hole. This is a lot of jumping, guys. Walking, walking, walking. There's another hole I have to jump over. Walking, walking, walking. Looking, there's a fence I have to jump over. Walking, walking, walking. There's a hole I have to jump over. And then I'm good. So every time something stops, right, a hole or a line, so a fence, you have to jump, you have to stop and restart. You have to jump over it. All right, let's look at our increasing and decreasing. Negative infinity to negative 4. Right, that's going up slightly. Then negative 4 to negative 3, that is going up. Negative 3 to negative 2. Now this is the weird part. If I look at negative 2 to 2, it's going up and then down. So only this part here is going up. So negative 2 to 0 is where it's going up. Then from here to here, it starts going down a little bit. So 0 to 2, 2 to 3, 3 to 4, 4 to infinity. Okay? I'm going to let you know, this is a crazy problem. One would never be this difficult on like a test or a quiz or anything, but it's good to kind of see how many different things you can have, and that at every single jump or whatever, we have to jump over it. All right, let's look at our range. We have our horizontal asymptote. Right, it has a line right here that nothing's really going over. So we also have to be careful of our holes though, right? So I'm going up. On this line is where our holes are. That's hitting us right as we get to negative 1. Then negative 1 to 0, we hit the fence. And then 0, there's some holes here at 1. And then we can keep going. Okay, so even our range has lots of stops in it. And finally our end behavior. The limit as x approaches negative infinity of f of x equals, right? What's happening over here? It's going towards 0. The limit as x approaches infinity of f of x equals what's happening over here. It's going towards 0. So a lot of times those will be the same thing, and it will be pretty much every time it'll be your that horizontal asymptote. Okay. All right. That's all we're gonna look at in our video tomorrow in class. We're gonna look at some of these graphs, or we're gonna look at these two that are on our calculator. And then we'll do lots of examples tomorrow. All right, have a good day.